Hi, this is Celeste from the Celestial Report, and I am back and we are doing NanoMoments. I had a relocation, and now that I'm relocated, it's time to get back to work, and the journals are brimming with information that you want to know. So I am going to share my screen. So let me do that. Let me get to NanoMoments and let me see if I can get this bigger. I don't know how to make it bigger. Where is this thing? Bigger. Oh, there it is, but I can't make it too big. Ah! Okay. Yeah, we made it too big. Okay. So this is NanoMoments for July 8th, 2021. And pretty much, I mean, today we're going to look at Applied Nanomaterial Journal and see what they have to say, because it's very interesting. And I want you to pay attention to this particular one. This is a three-dimensional photoluminescent crypto image doped with, I'm not even going to read that, quantum dots by 1 photon and 2 photon polymerization. And that sounds like a real mouthful, but I want you to take a look at this image. It is amazing. So remember back when I was talking about the nanocubes, and it had the foundational substrate, and then it had the quantum dot or hydrogel ink that could potentially put the seal or the image of Satan in it, so that the person taking this nanocube injected into their body would have that image inside of them, and then it's encrypted. So I did not know the mechanism. I just knew that that's what was being described. But today, voila, we have the mechanism on how they're doing it. They chose the Mona Lisa. And this was a 3D photo emission. And how it came about was these 3D dots, 3D quantum dots that are hidden and encrypted, and they put this image. I liken it to, so when I was in high school and it was the punch key card day, and I would, one time I did Snoopy, and other people did other things. They did houses and buildings and that type of thing. So it's much like that, only these are going in people's bodies. So let's look a little bit at what this is saying. So this is quantum dot. We're not really talking hydrogel here, although hydrogel has many of the components and it could basically do the same thing. Polymerization, it has to do with chemical structure. Photoluminescence, a lot of you are reporting this luminescent quality to people. And yes, they are trying to turn us into luminescent beings because, of course, Lucifer was the angel of light. And then lasers. So how does this work? I kind of broke it down a little bit, and where it gets too technical, I'm just going to skip over, but you are, feel free to go to the journal itself and look at all the graphic details. It's 3D, photoluminescent crypto images can be created by nano patterning quantum dots with polymetric micro object. So that is like that quantum, or the cube, nanocube that I was talking about. A UV sensitive photoresist, and then it's doped with this particular shell, and it is employed to fabricate fluorescent devices by 2-photon polymerization, direct laser writing. And remember, that's lithography. Laser writing is lithography at the nano level. And so I talked about that in the Nanocube presentation that I did. And if you've missed that, you might want to check it out. So by opportunely combining excitation and cross-linking physical phenomena, it is possible to control the local density of the quantum dot with nanometric resolution, and therefore to tune the local photo emission of the fabricated polymetric structure. So, basically they can make Snoopy, they can make the Mona Lisa, they can make Satan. It's up to them, depending on how they do the dots in their nano quantum patterning. So let's see. And then they tested it, and then the best conditions to create nanostructures containing only a few quantum dots to be integrated into optical devices, as well as to create 3D photoluminescent micro crypto images. I guess this sentence really concerns me, because here are just a couple quantum dots will be integrated into optical devices. Does this mean that your glasses, your contacts are going to be giving you images? Remember, a lot of these are remotely controlled, so the frequency, or there's other triggers, might trigger you to see things, images, hallucinations, if you will, that are not even there. It is to get you desensitized and to usher you into this new virtual reality where they want you to be completely immersed. So then it goes down by TPP and the laser writing, and 1-photon lithography, a 3D fluorescent design can be concealed inside a polymetric microstructure that is swiftly fabricated using a photoresist. So they're admitting that it is concealed inside a polymetric microstructure that you may or may not see, or you may or may not know that it has this pattern or design inside. And the image, the 3D crypto image, is shown to illustrate this technique. And what you want to come away with, the buzzwords for these would be quantum dot, 2-photon direct laser writing or lithography, and photoluminescence. That's one reason people are getting luminescent, that they have run into this somehow. Now we have another article, whoops, there I go again, from Nanomaterials, and it's the nanoparticle size effects in biomedical application. This renal clearance is your kidneys clearing out the nanoparticles, and this is there's an electrical effect, and there's a photomagnetotherapy. And remember that, because this is one reason they are changing the magnetism in our body. It also allows for a plasmonic detection, and we're going to be going through that in my next webinar, which is in about 6 weeks. It is much like an MRI contrast, but it is very different because it is persistent and it stays in your body. It penetrates the membranes of your cells, and then the cells uptake it into the endocytosis and then lower uptake. These are the sizes of the molecules that we are dealing with: 10 nanometers, 50 nanometers, and 100 nanometers. So it is pretty small. And also it has to, the curvature makes a difference on what its ability to do. and also its colloidal stability. Will it be colloidal? Will it stay suspended in a fluid? So the nanoparticle size plays a central role in determining material properties and performance in biomedical applications. And that's why the nanoparticles are being used are for biomedical application. A wide variety of functional nanomaterials and nanobioconjugates have been developed for monitoring biochemical activity, controlling biological function. Listen to that, controlling biological function and therapeutic applications. This review focuses the role of the nanoparticle size from 1 to 100 nanometers in various biomedical applications, the origin of such size effect, and the optimum size requirement for the best performance in different biomedical applications. So then it goes on, but we'll finish up. We highlight some of the best designed nanoparticles for optimum size for specific biomedical application. And finally, we attempt to correlate the origin of the evolutionary selection of various nanoscale units in life processes toward specific biological functions. What does that mean? It means that through this technology that they're describing, they are going to evolve mankind towards specific biological functions that the agenda wants, that the elite want. So that's just something, that's one reason for these nanoparticles. So what are the key words that you want to remember or keep your eye open in the media? Nanoparticle, size, effect, biosensor, imaging, in vivo targeting, and therapy. Now here's one that is also comes to us from Applied Nanomaterials, and that's silicone coated, I'm not even going to say cellulose nanofiber aerogel films with photothermal and Joule heating performances for electromagnetic interference shielding. So I thought that you guys might really be interested in this one. So the subjects are the chemical structure, the carbon nanomaterials, nanofibers, and of course aerogels, and those are a part of the geoengineering. So this is what it looks like. They are, as they integrate this silicon into the nanoparticle, it becomes water resistant. That's hydrophobic. It does not like water. It shields from electromagnetic interference. It has a photothermal, so it will act as a trigger. So when the laser hits it, it will trigger certain nanoparticles to do certain jobs. And it can also heat up, and that's hence the Joule heating. So let's read a little bit about it. Aerogels with a larger specific surface area and lightweight property have aroused tremendous attention in recent years. Functional aerogel materials have shown application in the fields of industry, environment, biomedicine, and so forth. Of course, it's very vague. In government, they always do very vague, and that's where the interesting stuff is. Herein, multifunctional composite aerogels of cellulose nanofibers, and that's some of those fibers that you guys are seeing when they grow, and they do have MXENEs and silicon, and they freeze dry it, and then there is a coating process afterwards. I'm not going to bore you with all of the techno talk, but I did want to go down here because there was something. So what are these going to be used for? Considering the characteristics of hydrophobicity, high EMI shielding efficiency, and superior Joule heating and photothermal performances, multifunctional silicon MXENE CNF aerogel films will have promising application in intelligent garments. Those are garments that are part of the hive, part of the quantum computer, and as far as EMI shielding fields. Now you are going to have to determine whether you want an intelligent garment that could potentially shield you from electromagnetic radiation, but it's connected to the quantum computer. So do you want it or do you not? The choice is going to be yours. At least you know now that it is out there. Then I don't know why I didn't put the picture on this one. This one is chromium doped zinc gallate near infrared persistent luminescent nanoparticles in autofluorescent free biosensing and bioimaging. And so the subjects are biological imaging, optical imaging, luminescence, energy levels, and biosensing. So let's find out a little bit about this. I found this really interesting. So here's the design, the synthesis, the structure, and then it becomes luminescent. Now look at this. This is the yin yang. And you got to know that most of the scientists developing this, all of a sudden I am seeing a lot of the yin and the yang in these peer-reviewed journals. All of a sudden there's a flood of it. So just notice there's white and black and the yin and the yang, and it's associated with the bioluminescence. Near infrared persistent luminescence, that means it does not go away, nanoparticles, and you need to know the acronym in case you run into it. It's PLNP. Government, military, and researchers love their acronyms. Are emerging optical probes that can emit a NIR, near infrared light, for a long time after light illumination has stopped. Near infrared light, persistent luminescent nanoparticles can completely prevent autofluorescence caused by excitation light, thus considerably improving the sensitivity of biosensing and bioimaging. So what is autofluorescence? So that is self-induced fluorescence or fluorescence and light emitted during absorption of radiation of some other invisible wavelength. So that might be cosmic rays, for instance, or when you're born, there is a light. And at the end of your life, there is a light. And if you're in Jesus Christ, there is a light within you. And this actually can distinguish that light from this persistent luminescent nanoparticles. What they were saying, and their problem was in the past, that they couldn't distinguish between their synthetic photoluminescence and the luminescence that God creates. And then some creatures have luminescent capabilities, like some fish and that type of thing. So they use a doped chromium to make this. And look at this. It is, so this near infrared persistent luminescent nanoparticle has drawn extensive attention because of the excellent persistent luminescence. And that means that the person or the plant or the animal stays luminescent as a result of these nanoparticles. Look at what they call this. Look at the acronym, personal property. That now personal property has to do with your luminescent, your degree of luminescence. High chemical stability and variable excitation light sources, whether it's UV light, LED, near infrared laser, X-ray, or radiopharmaceuticals. So therefore, the ZGC nanoparticles have been widely used in autofluorescent-free biosensing. So the keywords for this are near infrared and persistent luminescent nanoparticles and autofluorescent free. And here's another one from Applied. I didn't do so hot on taking out all the authors, but now you can see they're mostly Chinese. Silica-based nanopipettes for rapid living cell transfection. So let's go down. I'm sorry, I guess I must have got distracted maybe with Mississippi. The subjects include etching, so that could include lithography, fluorescence. So as you can see, they're really getting into this fluorescence, amorphous materials, drug delivery, and imaging probes. And here is an example of what they're talking about. And I am bringing this to your attention because this is an intercellular delivery of materials, drugs, with nanopipettes has become a critical method in gene editing, which we're familiar with, and cell-based therapy because of its nanometer scale features capable of penetrating the cell membrane and targeting very specific subcellular compartments, directing materials to the endoplasmic reticulum, to the nucleus, mitochondria, for example. The geometrical perimeters of the nanopipettes directly affect delivery efficiency. So this intranuclear injection of proteins to living cells with a high spatial resolution is finally realized. Single cell, let me get down here. Single cell transfection through intercellular delivery of plasmid based on a self-built living single cell workstation has now been completed. So we're going to be talking a lot about the plasmid workstation in the next webinar, so stay tuned. And this technique is expected to be used in the treatment of diseases for high resolution localization of organelles in living single cells without fluorescent labeling, and subcellular omics analysis by mass spectrometry. And so your key words are nanopipette, controllable fabrication, wet etching, living single cells, and intercellular delivery. And this one also comes from Applied Nanomaterials. That one that I don't know, I can't remember. This is pretty much about graphene. And the reason that I put it in here is because it's talking about its exceptional electrical conductivity, outstanding mechanical properties, and processing versatility desirable for hybrid integration. And then it goes into that. And I do believe that this particular one has a paper that you can read for more information. Our primary focus is to systematically classify various types of memories in view of their material, structural, and functional characteristics. Memories, you guys, memories. For this, the shapes and the composition of the conductive channel, the key operational mechanisms underlying the electrical functionalities, and the major characteristics of representative device structures and material systems are carefully evaluated. Furthermore, the accessibility of flexible graphene memories. So this is now we're getting to the heart of the matter. Graphene memories to the neuromorphic computing area is discussed. So basically, this is talking about getting graphene into your brain and creating graphene memories. And that is scary. And they're pretty excited about it. So it's flexible electronics. And what have I been saying? Talking about soft robotics. Graphene is the base element that they're using, memory devices, and plastic substrates. Now, this last one, and then I'm going to wrap it up for today, is an article, and I'm not going to go into it, but we will put the link up for you. Mammalian and fish gelatin methacryl alginate interpenetrating polymer network hydrogels for tissue engineering. This was pretty interesting because, as I've been saying, anything gelatin now can contain hydrogel or quantum dot, and it is now not kosher, if you will, or politically correct to use anything mammalian. So they are going to use fish gelatin. So this particular link right down here, and it comes from Omega, the journal Omega, goes into great detail about this fish gelatin and how they're going to get these nanoparticles using the fish gelatin alginate into our bodies, turning us into these soft robots. So you might want to check it out. I didn't go into it. I'm leaving that for you to do your own homework. And we will see you next time on Nano Moments.